Hello. In this video we're going to work through this question here, and this question has come up in our unit in quadratic relationships, and students inevitably ask, why are you now asking me to find the equation of lines? A couple reasons. One is finding the equation of a line is something you should be able to do, and it will come up regularly in many questions as you go forward. So it's really important to keep this skill of yours practiced. Secondly, we're taking time right now to figure out the equation of a quadratic given some specific information. And we pick the best form based on the information given. I really want to make that connection that you've already been doing this with linear relationships. So this is a good opportunity for us to come back and practice this skill and make the connection that we're doing something we've already done, just with slightly different algebra. Okay, so before we do this, let's actually remind ourselves of the different forms for a linear relationship. Our first form, and probably the most common, is slope y-intercept form. And that is the form y equals mx plus b. And of course, m is equal to your slope, and b is equal to your y-intercept. And so we can say that the graph will have the point 0, b. The next form, which is commonly learned when you're first learning about linear relationships, is called slope point form. And I'm going to do two steps here. We're all familiar that the equation for slope is y2 minus y1 over x2 minus x1. And so what we often do is we rearrange this and we end up with y2 minus y1 is equal to m x2 minus x1. So we've simply multiplied both sides by the denominator here. And all we need in this case is, we know that m is equal to the slope. So we need to know the slope for this form. And we know the point x1, y1 is known. So if we know x1, y1, we can substitute in x1, y1 and m. Often you'll see it written like this. Sometimes you'll see people say y minus y naught is equal to m x minus x naught. Again, the key thing to remember is you just need a point, and you substitute in that point to an x and y pair, and you need the slope. You could, if you wanted, substitute x into here and y into there, but typically we substitute into x naught, y naught. The third form, which is a little more uncommon, but a great form, I always recommend students learn this one, is called xy-intercept form. This is a great form because it allows you to practice your algebra when you're doing some manipulation, but also it means if you're given the x and y-intercept, you can work at the equation very quickly. X over a plus y over b equals 1. So that's xy-intercept form. Make this a little neater. So what we know is that we have the point a comma 0, which is the x-intercept, and we have the point 0 comma b. So if you're given the x and y-intercept, this form is very useful. The last form, and this is the form that we want to leave each example in, is called standard form. And standard form is not super useful in terms of going from some information to the equation. It is useful with some algebraic techniques, which some you've developed, that is systems of equations, and some that you will be developing as you move forward. Standard form, we write the coefficients as capital A, capital B, capital C. Of course, these unknowns can be anything, but what I want to discourage is that you use small a, small b, and small c. Because if you do that, sometimes students will think of their quadratic relationship. Okay, so now that we have these four forms, let's work through these questions, shall we? Again, no form is wrong to pick. It's just, it depends on, by picking the best form, the question will be easier. So if question A, I have a point, So we have some point, let's call it P, and we'll put negative 5, 8. And we have 3, 0, which is the x-intercept. So if I take a look at my forms here, I don't have the x and y intercepts, so that's not useful. I don't have the slope, so both of these forms aren't particularly useful. So first thing I'm going to do here is I'll calculate the slope. So m is equal to, and we're going to find the slope between these 2 points, so 8 minus 0 over negative 5 minus 3, and we end up with 8 over negative 8, which is equal to minus 1. So therefore we have y equals negative x plus b. And now just simply substitute in a point. So let's substitute in the point 3, 0 into this. So we get y is, pardon me, we get 0, which is the y, is equal to negative 3 plus b. So therefore b is equal to 3. So the equation of our line is y equals negative x plus 3. But of course, I've asked for this solution to be in standard form, so we have to move everything to one side. And so what we're going to do is I'm going to subtract y from both sides. So I end up with 0 is equal to negative x minus y plus 3. Now some people might have added x and subtracted 3 to both sides, and they would have ended up with this, x plus y minus 3. Both of these versions are correct. Remember, when you were learning systems of equations, as long as we multiply both sides by the same value, it's the same line. So it's important to kind of highlight the point here that there's more than one possible form when you're working in standard form. Usually we divide each of the coefficients by their greatest common factor. Okay, let's do the next one. Let's work in black. So B, I get really excited because I see I have the x-intercept and the y-intercept. So we know it has the point negative 7 comma 0 as well as the point 0, 3. So I can very quickly use x-y-intercept form, and I can say x over negative 7, and often we'll write it like this, plus y over 3 equals 1, and I'm done. So now I want to change this to standard form, so I'm going to multiply both sides by a value which will allow me to cancel out the denominators. So if I multiply this first fraction by negative 7, it's going to go away. And if I multiply the second fraction by 3, the 3 will cancel out. So we can multiply both sides by negative 21. And if I multiply both sides by negative 21, so we can write a middle step here. So there's a step along the way we could write. What we're going to get is we're going to see that we end up with 3x plus, not plus, pardon me, minus 7y is equal to minus 21. And of course, now I want to convert this to standard form, so I'm going to write it as 3x minus 7y plus 21 equals 0. And I'm done. Let's highlight that guy. I like to put boxes around my answers. The reason why is because if you are interested in writing the AP exam, you want to box your final answer. So let's do C now. It goes to the point 4, negative 2 and has the slope 2 over 3. So that's going to be slope point form. So I'm going to take this point. So I'll say y minus minus 2 is equal to 2 over 3 x minus 4. So we end up with y plus 2 equals 2 over 3 x minus 4. Of course, you could go directly to this form, but sometimes writing this step will help reinforce comfort with signs. So let's get this into standard form. So once here, what I'm going to do is multiply both sides by 3. And that's going to get rid of my denominator. So 3y plus 6 equals 2x minus 8. So once I have that, sorry about that, that was my a little rough writing from an earlier attempt that I forgot to hit save when I was done. So let's rearrange this, and we'll do this all in one step. 2x minus 3y. And if we have minus 8 minus 6, we're going to get minus 14. And I'm done, so I'll box that in. There we go. So there's that question there. It's a nice question. We really want to be comfortable with linear relationships, especially for those of you that are interested in taking calculus. If you're interested in AP calculus, especially because there's lots of questions that seem to involve the equation of lines in some manner. I hope that video helped, and of course, please feel free to ask questions, whether you're in my class or not. I really enjoy making these videos because they help me better reflect on how I present my information. Anyways, have a wonderful day.